In this video, we're going to be tackling a set of problem-solving techniques. It's something that we call internally triumphant problem solving. And so this is going to be a way to tackle some very tough technical problems, but you can actually use this in any size problem, both in your professional life, but maybe even in your hobbies or other areas of your life. Now, I believe this would probably be one of the most important videos that we create for the rock community. That said, I also know from experience that it's a technique that comes with a little bit of resistance. And it's not because it doesn't work, but because it takes a little bit of effort, especially in the beginning. And I just want to encourage you that I've used these techniques in lots of really crazy tough problems, and I know for a fact that they work. So let's jump in. Let's take a look at some of these techniques. Before we look at actually the steps that we follow, let's look at a little bit of, get a little bit of an overview. One of my favorite quotes is from Doug Linder. A good programmer is someone who always looks both ways before crossing a one-way street. Now, this is all about caution and being careful and being observant. And this goes way beyond being a good programmer. I mean, pretty much anything in life could follow the same advice. In fact, I saw someone actually respond to this on Twitter once, and he said, "I must be the best programmer then because I look above and below too." And again, I love this response because it shows you the engineering mindset that if you want to tackle tough problems, the first thing you need to do is be observant and be careful. Now, some of these techniques I learned while working at Allied Signal Aerospace. I had the great opportunity coming out of college to work for this organization. While I worked in the IT department, I actually was assigned to and worked mainly with the engineers. And the engineers at our facility worked on jet engines, but also turbine engines, gas turbine engines that were used in M1A1 Abrams. So what I loved about this is the level of caution and care that went into these products. Obviously, a jet engine, you don't want to have mistakes. And when there is an issue, it needs to be treated very carefully. And you need to make sure that the fix is the right fix. Now, a lot of these techniques come out of some Six Sigma training that I was able to attend, some classes with the engineers to learn some of these techniques, TQM, Total Quality Management, Six Sigma, and I learned these techniques while getting my green belt in Six Sigma. Now, there's two responses that you can have when you come face to face with a huge problem. The first one, and it's a natural one, is fear. So when that call comes that there's a big problem, none of us really want to address that. It's kind of scary because you don't know what the answer is. You don't know what's going on. All you know is there's a lot of pressure to get it fixed. You might think of a check-in issue on a weekend, or it could be an issue during the week that affects the stability of Rock and maybe your website and all your staff are using it. So these things come with some fear, and that's okay. I think the first thing we need to do is just understand that that's normal. That fear can sometimes mean that it becomes a little bit of a hot potato, that issues can be thrown around. No one really wants that issue on their lap. A lot of times people want to just pass that on to somebody else, make it somebody else's problem. But at the end of the day, someone needs to own the problem. Someone needs to take hold of it and see it through. And I want you to understand that this process is the first step in reducing that fear. If you can trust the process, you should be able to reduce a lot of fear. But that fear is natural. No matter how much training and experience you have, the brave men who stormed the beach in Normandy, they still had a ton of fear. And that fear, it didn't matter what your rank or level of experience was. There's still going to be fear, and that's okay. Accept that. Courage is not the absence of fear. It's just putting fear aside and still going into that. And trust me, none of the technical problems that we have to deal with are anything near as dangerous as what these soldiers had to experience. So I said that there's two ways you could respond. One out of fear. Another way you could, and some choose to respond, is kind of out of laziness. They don't really want to be responsible. They don't really want to tackle the problem. It's basically becomes, if I don't think about the problem, if I don't see the problem, it's not a problem. And this is very, very dangerous. Because if you just say, well, that's not really a problem, maybe it's intermittent. Oh, it's not a problem anymore, or I can't reproduce the problem. These are actually very dangerous things because problems typically come back, and they don't come back in the most opportune time. They come back at sometimes the least opportune time. So it's best to just tackle the problem. Just don't ignore it. Don't pretend it doesn't exist, sometimes out of fear, sometimes out of laziness. But let's start going into how do we actually attack this. Before we get to the steps, there's a few rules that we need to follow. The first rule is to protect the crime scene. So a lot of times people want to jump in and start like changing everything. Imagine going into like a forensic, crime scene, and you have people like, flipping books all around and walking all over the place. That would be a very bad thing to do to solve your problem. So things like log files, current configurations, timestamps. Sometimes like the timestamp might be the date and time of the last modified. It might also tell you who modified it. And we need to know that, not to point the finger necessarily, but just to be able to go to that person and figure out like what was going on, if they made a change, perhaps do some training if they need that. So the first thing is like do no harm and protect the crime scene, because a lot of these facts that you're going to need to solve these problems, you don't want to lose them by like stepping all over the crime scene. Next is focus. And a lot of times when you start getting into this problem solving, your mind can go all over the place. And some of the key questions that you want to ask yourself is, what is different? What changed? Those are two very, very important questions. This is especially the case if the problem was it was working and now it's not. Now, if this is a new problem, maybe you're rolling out a new system and it's never worked. Maybe there's some different things to look at. But a lot of times the problems that we're going to be challenged with are a system that was working and now it's not. And if that's the case, the two questions I'm constantly laser focused on is what's different, what changed. So much so that it becomes a laser focus. If someone's else on the team is talking about other things and it's kind of not thinking through these two things, that can get you off on a tangent, and I stay laser focused on those two things. Rule 3 is don't believe in fairy tales. Computers are 100% logical. Things don't just happen. There is a logical reason for why problems exist. And again, sometimes this rule can be used to get off on the topic of like, well, it's working fine now. We don't really need to worry about it. In my experience, in the decades I've been working in IT, I can't tell you some of the how crazy some of the people's explanations for a problem might be. So much so that I sometimes wonder if they actually believe in unicorns. Some of the rationale in air quotes that I've been told of like, oh, it must have been this, this, and this, and it's like, yeah, and the probability of that, you might want to go buy a lottery ticket on the way home. And that's okay, to think about that, but it's not okay because the problem's gonna come back. It's, if it's that rare, it's probably not the cause of the problem, and its problem's gonna come back. So an unsolved problem will always come back. It's kind of like a mountain lion on a ranch. It's better to hunt it down and kill it than to have to go around every day looking over your shoulder, wondering if it's about to attack you. Never assume that you found the issue until you've evidence beyond a reasonable doubt. More innocent people get sent to jail for this mistake. Worse, the killer goes free and is left to kill again. There's no better way to destroy confidence than jumping to an early conclusion that does not pan out. Imagine going to your senior leadership saying, yep, we found it. It was that, and that, and it's all good, only to have it come back. Do you think that builds trust, or do you think that erodes trust? So again, don't jump to fantasies. Don't jump to conclusions. Stay the course. Worry about it in terms of facts, not emotions. Rule 4 is a little bit like Rule 3, and that is, does it pass the sniff test? Again, before acting, does this explanation seem logical? And this might be when you're in the middle of the process, when you're testing hypothesis. Like before you start putting effort into it, does it really pass the sniff test? Again, sometimes we're trying to grasp at straws because we're nervous, we want to get this thing fixed, and so we start grasping at straws. And through every step, just make sure, does this pass the sniff test? Does this seem logical? Does this seem likely? Rule 5 is correlation does not equal causation. Just because two things correlate does not necessarily mean that one caused the other. And so I can't tell you again how many times I've been through this where two concepts are correlated and they create causation out of that. Well, it must be because of these two things. Like this and this happened, so therefore that could have happened. And again, if you put that through the sniff test, it doesn't work. So don't jump to conclusions. Okay, so these are some of the rules. Let's look at the steps now. So the first step, and this is especially important in large problems. If it's a smaller problem, you might be able to shrink this step, or if it's a very small problem, you might be able to skip this step, is to define the team. Determine who will be involved and what role they'll fill. Now, what roles might you want? A couple of roles that you might want. One is a champion, and this is especially needed in a large problem. This should be someone not emotionally tied to the finding of the solution. They will be responsible for determining if the resulting explanation is logical. And this oftentimes is a business leader. And if you can't explain what you believe the cause of the problem was, and that the fix it would fix that, if they can't pass the smell test with them, that's a good thing because they're not emotionally tied to it. We who are working on the problem are definitely emotionally tied to it, and we might jump to conclusions just to pretend that the problem is solved and we can move on and we can go away and there's nothing to see here. The champion is going to prevent that. They're not emotionally tied to it, and we have to be able to explain it to in a way that's rational. A recorder is very helpful. As you can see, there is some note-taking that we need to do, and having someone dedicated to that is great. A third role, and you could have more roles, these are just some of the common ones, is a communicator. Oftentimes there's going to be people surrounding the team, whether virtually or physically, who just want to see like what's going on. Is the problem solved? This is urgent. A communicator can kind of push them back, give the team a little bit of space, and will be the person who will go out and communicate them so that the rest of the team can stay focused on solving the problem. Okay, step 1, define the team. Step 2, define the problem. A problem well stated is a problem half solved, and that's certainly true. So before you jump out there and start wanting to look at the crime scene, let's define what the crime was. Let's define the problem well. Okay, so some examples. And I'm making these up from some previous experience and some previous projects, but like here's one. SMS pipeline is locking up when using a cluster. Or maybe a different problem might be the initial load of the mobile app is slow. Another problem could be the web server's CPU utilization is 80% when a small number of check-in kiosks are active. These are all very concise and good statements of what the actual problem is. No, we're not trying to solve the problem here, we're just trying to state the problem concisely. Statements should be clear and concise, and we don't want to add details that we're not 100% certain of. That might not have a bearing on the problem. Information that is not correct or relative can actually send the investigation in the wrong direction. So if we're not 100% sure of something, don't put it in here. And if it's not related to the problem, don't put it in here. So many times I've seen we're adding a little bit of add-on, to description that's not germane to the problem can send a team off on the wrong direction. Okay, step 3, classify the problem. Is this an easy problem or a difficult problem? If it's an easy problem, there's probably less stress. You can probably, tackle the scale of this solution in a different way, or the scale of this process in a different way. And I think it's important to just say, hey, is this an easy problem or is this a difficult problem? Now, know our initial mindset is going to be berserker. We're stressed. We want to get this problem fixed. We're not always the most, we don't all have the most engineering mindset of being very patient and concise, and we'll go into berserker mode. Now, if it's an easy problem, that might be appropriate for a short amount of time. If it's a hard problem, I wouldn't go there even for a minute. The more time you spend in berserker mode, the harder it is to get the problem solving back on to the right ground. I've seen this before where a team might have been working on a problem in a kind of like a berserker mode for several hours or even a day. And then I'll find out and I'll step into it. And it's really hard to get that out of berserker mode because they haven't been following the process. And now getting them onto the process is a lot harder because they're further down the path and there's more resistance and reluctance to actually use some of these tools that we'll be talking about. Instead, we want to have a desired mindset of a research scientist. We want to approach this very cautiously, very carefully, and very with little to no emotion. So step 4 is to create a timeline. Document the timeline. A timeline is a key fact to document. When did the problem start? When was the last known successful run? Again, what changed? What's different? If you don't have the timeline, you can't understand that. When was the last update to code change made? I've seen so many times where code changes or the code has been thrown under the bus when it hasn't changed in like 6 months. So then I go back to what's changed and what's different. And the code is not different. So it's very unlikely that the code was the cause of the problem unless something else like a configuration changed or the use case changed. But typically code is one of the first things to get thrown under the bus. But if it hasn't changed and you documented the timeline, then you can at least reduce the likelihood that it is the code. Okay, step 5, and this is a very important step, and that is to start a fact list. To find what is true and what is known. And you want to document this. You want to write this fact list down. This is not something you just start talking about. You have to either put it on a whiteboard or put it on paper or put it onto your computer. You got to have this. So some specific facts, maybe going back to this SMS pipeline example that we talked about earlier, is fact. Sending groups, texting the word groups to the SMS pipeline causes the server to lock up. Another fact, the server is a clustered environment. A third fact, no exceptions are thrown. Now, some of these might seem very obvious. The server's in a clustered environment. You might think, well, gosh, everybody around me knows that. It's still important to write that down. Why? Because it's very likely that you're going to be pulling in new people or different people as this problem persists. Having a fact sheet that you can turn over and bring that person in will get them up to speed very quickly. Now, you don't want to put facts here that aren't important. So make sure that the facts are specific and most importantly correct. Man, if you put a wrong fact onto your fact list, you can just really nuke your chances of solving this problem quickly. 2, only add facts that could be specific to the problem. Don't add facts that have little to no likelihood of being related to the problem. So you don't want to put every single fact down, just the ones that you think are pertinent to the problem. 3, continue to add facts as they become evident. So as we continue down this process, you're going to see that we're going to find new facts. We're going to think of new facts. You want to keep writing those down. Again, I want to pause and just say again, reiterate, this is so important that you create a fact list, and that fact list is on paper or whiteboard or electronic. So many people skip this step and it is so difficult. It's a handicap to your problem solving. Not only for the team that starts the problem, but for when you bring other people in. Be careful not to twist the facts to fit the problem. So sometimes we can kind of twist the fact to say, well, I think it might be the code. So now you're twisting the facts a bit. That can really get you off on the wrong path. Okay, some other tips, like what might you want to think about to help create this fact list? When did the problem start? I mean, it goes back to that timeline. What changed? Again, one of the most important questions you can ask. What activity, human like events or machine like jobs were going on at the time? So when you think about when the problem happened, was there any like human interactions that were abnormal? Was there a huge event happening on site that maybe, impacted the check-in? Or maybe it was when at the same time as a job was running within Rock. Look into what other things could have been happening at that same time. The fourth bullet point here is a really good one. Never trust the witnesses. And I think if you ask, a detective in the police department, they'd probably tell you the same thing. Listen to them, write down what they're saying, but don't trust it implicitly. Sometimes witnesses tell you things that they're not untrue, but they're not necessarily helpful, or they might be a shading of what they saw. And I think, again, if you ask the detective to describe a traffic accident, and 4 different witnesses are going to give you pretty much 4 different stories. They might all have the same truth, that 2 cars hit each other, but the stories they tell you will be different. So never fully 100% trust the witness statement as fact, but do consider it and do write it down. Step 6 is to create a probability tree. Break down the possibilities with probabilities. So again, it's going to be very tempting to jump and just start doing this. Let's try this, let's try that, and start taking action on that. But you want to stop. It's so important that you stop and think about, on a whiteboard or again on paper, what are the possibilities here? So here I've drawn out a very simple probability tree. So problem statement is the SMS pipeline is locking up when using a cluster. I'm then going to create what are the possible places that we could be having a problem. Is it Twilio? Is it the pipeline code? Is it a specific SMS action? Is it maybe something to do with the cache code that, to Redis, because it is a cluster? Could it be something in the infrastructure? These are all possibilities. Now, we're not really worrying at this point how probable these are. We're just going to put out all the different possibilities. Just brainstorm that for a second. Once you have it brainstormed, then you can go back through and put in the probabilities. So here you can see the probability of it being in Twilio is super low, right? That's probably not where we're going to go to first. It's good that we put it out there, but it's fairly unlikely that that's the case. Now, once you've created this first row of possibilities, you can kind of break it down a little bit more and say, okay, well, if it was a specific SMS action, which we're giving it like the second likelihood, let's list out some of the actions. Like, is it the first action? Is it the second action? Is it the third action? And we can even break out that probability there too. Okay, once we have our probability tree started, we want to start going through basically the scientific method. So we want to design some experiments. We want to find actions that can rule out one specific item on our probability tree. Okay, so for example, we're not just going to go start getting to work on this. We're just going to quickly as a team decide what our experiment is to rule out one item on our probability tree, or at least to provide more insight into the likelihood of our probability tree item. So again, we're not going to jump in there. We're going to take the scientific method. First, we're going to say, what's our hypothesis? And in this case, we're going to say, I believe that the lockup has something to do with being in a clustered environment. So how am I going to test that? To confirm that the issue has something to do with being in a clustered environment, let's take one node out of the cluster and send the SMS message to it and see what happens. So by removing it out of the cluster and sending the message to something now, basically we're declustering our environment, we could see, well, maybe that would have something to do with it. And we should document that. What is our expected result? I would expect that the node would not lock up after being removed from the cluster. Okay, so now again, you might think, well, yeah, I got that. Let's just go. Like, we don't need to write this down. And I think that would be a mistake, because these experiments take time, and you need to do them with a lot of care and a lot of thought. So here's some tips. Your test should only change one factor at a time. If you start changing multiple factors at a time, you don't understand which factor it could be in play. Now, if it's a big problem, you could perhaps try to rule out a couple factors at once and then come back and test each one of those if it turns out that brought clarity to it. But in the beginning, I highly recommend only one factor at a time. Consider your current facts to determine if the experiment's hypothesis will make any progress in the understanding of the problem. Again, as you brainstorm some of these, you'll often find that what your hypothesis and your test, they actually won't really help with understanding the problem. Definitely want to keep a log of changes so that it can be changed back afterwards. So many times people do a test, it didn't work, so you go on to the next test. Well, now that you're leaving a trail of changes behind you, and there's no way to know whether your changes, which change helped, because maybe it was a amalgam of several different changes, or you might be leaving problems, landmines behind you that you're going to step on later. Fourth, determine what was learned from the experiment and add it to the fact list. So the fact list is not a static document. You're always adding more information to the fact list as you go. Okay, step 8, reevaluate. Update your probability tree and your fact table. So as you learn new things, if you can scratch off something off your probability tree, well, that should change the probability of all the remaining items, right? Or maybe you learn that, oh gosh, I think maybe this is, after doing this test, we really actually feel more confident that this is the item. Update your probability tree. Just scratch it off. If you did it on paper, it doesn't have to be pretty. Scratch it off, put your new percentages. If it's on the whiteboard, erase the percentages, put the new ones in. Okay, so you want to reevaluate. And now what you're going to do is you're going to kind of skip back up to step number 5. And you're going to go through it again. So you're going to go 5 through 8 in a looping fashion until you find the problem. The final step, step 9, is to do a postmortem. So now at this point, you've actually solved the problem. You've gone to your champion. You've explained the problem. You've explained your solution. They've signed off that, yeah, that feels like that was the right solution. And you can now feel confident and breathe a sigh of relief and move on to step 9. Now, again, I think a lot of people are going to see this. They're going to say, this sounds great. But when the problem comes, that day that comes, when the problem is there, you're probably going to maybe think about some of these things, but you're not going to do this whole these steps. And I would, again, highly encourage you to follow this process. It works. I've seen it work where a team has been working for numerous hours trying to figure something out. And when you bring this tool into that problem-solving team, within 20 minutes, you can actually find the problem because they're in berserker mode. They weren't in research scientist mode. And these steps aren't my steps. These steps are from engineering teams and tool sets within Six Sigma and total quality management. So let's talk a little bit more about step 9, postmortem. So this is a summary of what happened with the purpose of prevention and training. So some of the things that you might want to document, again, the problem summary, who is involved. Who's involved is actually really nice because if you ever need to go back to this in the future, you can go, hey, this happened once before. If you document who is involved in the problem solving, you can go back to them and get more insights. Document the impact. What was the impact to the organization? It might seem very obvious, but you don't have to spend a lot of time typing up a big impact. Just document what it was. What was the solution summary? What was done to fix the problem? Contributing factors. Oftentimes, it's kind of like a plane crash. Typically, planes don't crash for one problem. It's a combination of problems. And that might also be the case in your environment. Sometimes it wasn't just one thing that went wrong. It's several things. And it just, the combination of those things is what caused the factor. Next up, lesson learned. What can we learn from this problem solving? Be sure to document these for current and future team members. How could we prevent this problem? A lot of times you'll find that the problem that you ran into actually is preventable. You can write some scripts, perhaps that could notify you or alert you. Certainly the case, I've seen this in the past where like file systems have filled up on a server, like the C drive would just fill up. Well, happens once, shame on you, happens twice, shame on me. Because we could put prevention in there. We could have alerts when an operating system's file system is near full. And then action items. A lot of times this is going to take some time to do these things. So what action items could you put in place to finalize those preventions and to actually clean up some of the mess that might have been made? Okay, so those are the 9 steps. Highly, again, encourage you to go through those 9 steps. But here's a few more tips and tricks as you go through this. One is divide and conquer. You can split the problem in half and test each side. So a good example of this happened once when I was working at CCV, huge network, right? Huge network. And we were having a pretty large network problem. The network would just drop occasionally. And so we didn't know where that problem was on this huge network. So fortunately, during the week, we have the opportunity where we could actually, detach big portions of the network, and that would be okay. A lot of the buildings aren't being used. And so we knew this problem was somewhere in the network. One of the switches was causing this problem. And so we basically turned off half the network and determined, well, is the problem still happening? Yes. Okay, we'll turn off some more. And then until we could eliminate a lot of it and say, okay, well, the problem is somewhere in this area. And in that case, is actually a weird problem. It was a network cable that someone had run underneath a door, and the door had rubbed the network cable down to just bare wires. And so occasionally when someone would go through that door, those wires would short, and it'd short out that switch, which would actually, ironically and weirdly, short out all the switches. It never could have found it if we hadn't divided and conquer. So divide and conquer is a good technique. Just make sure you're documenting it and you're doing it in a very scientific way. Traffic logs, especially when dealing with like issues with web environments, looking at the IIS logs or the log files is extremely helpful. I can't tell you how many times this has helped us solve a problem. And typically when I'm going through those log files, I'll actually find other problems in there as I'm looking at it. And those are great to move on after you do your postmortem. But the traffic logs are very, very, very helpful. ROC's exception log is very helpful. One of the first things I actually go to. Most errors and exceptions in ROC are logged, and there's a ton of rich data inside of those. Fairly new is also something called ROC log. So that's a setting that you can go in there and you can turn on logging for your server. By default, it's turned off for performance, but you could turn that on. There's not a ton of things that we can log right now, but there are some pretty nice ones, and we're always adding more. So that's more of an advanced one, and probably be even more powerful in the future. A concept I put into a different video, I think that's out there right now, is the concept of a mole and a meerkat. And sometimes you need to come up for air. Sometimes you're digging into the problem like a mole, and you just keep digging deeper and deeper and deeper and deeper. And sometimes you just need to stop and say, whoa, 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 I need to be now the meerkat. Put away the mole, and now I need to be a meerkat. Stop, put your head up, look around, try to make sure that you're still heading in the right direction. So many times we can keep digging our hole deeper in the wrong direction. And that's where you want to be thinking like a mole and a meerkat. Another thing is, just look at metrics. Metrics are crucial for helping understand problems. So as an example, let me show you this issue that was raised by somebody. I was working with someone in the community looking at their IIS metrics, and this happened to be on the SQL side. Okay, so they showed me their SQL metrics, and that's what they showed me. And I was like, whoa, that seems odd. Why is it odd? Because it seems so consistently high. It never goes below 30%. And if you're familiar with what metrics might look like, typical metrics for a database server, it's definitely never always a 30%, at least not in a ROC environment, okay? It's spiky for sure, but it typically hovers much lower than that 30%. And I was like, well, that's really strange. We should look at this. And so one of the things that you need to be cognizant of is you don't want to always use these aggregate metrics. And the aggregate metric might be helpful, but if you're zoomed out, it's masking a lot of good data. So if we zoomed in on his metrics and looked at like it in like 30-minute chunks, it looked like that. Same data, right? But it has a different shape now because we're zoomed in. And so if you look at this, that's so consistent and so repeating on the right time that you can pretty much assure that that's not user interaction. Okay, that is the machine doing something on a beat, right? And so what would be the likely cause of something running on a beat inside of Rock? And that would be a job, right? So we started going through the jobs and we started turning off certain jobs, one at a time, a couple at a time, putting those back on, trying to find the job at fault. We found the job at fault. We fixed the issue with that job, and then the traffic looked like that. And so that is more like what you'd expect a Rock database to look like. So knowing metrics, looking into metrics can really solve a lot of problems, because what was reported was, Rock feels really slow and it seems consistently slow. So it's kind of like a needle in the haystack kind of statement. But if we start looking at the metrics, boom, it allowed us to laser focus right onto that problem. So those are some tips and tricks. I hope that the process that we've explained here is helpful. I know it's saved me several times. It's reduced so much stress. There is going to be stress, but it reduces it. And I can say from experience, I always try to use this process, and it works. So many times I brought this process into a team that was already in berserker mode for a long time, and by establishing the process, we can quickly and calmly find the solution. And so I hope it's something that you can use and that you find benefit in.